Hello, welcome to Unit 6. This unit is about gas laws. In this unit, we will be covering the characteristics that make up ideal gases, what the mole is, and the ideal gas law. To be an ideal gas, an element has to meet certain characteristics. Number one, it must have insignificant volume. What this means is that the particles are extremely small in size or quantity that make it insignificant or unimportant. Number two, the gas particles do not have intermolecular forces. This means that the particles in the gas do not attract or repel each other. You could think of it like the particles ignore each other when they come across one another. Number three, the gas particles must move randomly with no specific pattern of motion. And lastly, number four, the gas particles do not lose energy when they collide with other gas particles or the walls of the container they are in. Now we are going to talk about the mole. Before we get into the ideal gas law, you need to know what a mole is. It is not the animal. In chemistry, 1 mole is equal to 6.02 times 10 to the power of 23 particles in the form of atoms or molecules. This is an important number to remember. When written, mole can be shortened to mol. So you can say 1 mole or 3 times 10 to the power of 4 moles when describing the amount of particles in a gas. Again, to clarify, a mole is just a unit. Just like saying 1 dozen is equal to 12 things or 1 century is equal to 100 years, a mole represents an amount of something, and in this case, the amount of something is particles. The important note to remember is that a mole is equal to 6.02 times 10 to the power of 23 particles. Now let's take a look at a mini example. Let's say you're asked, how many particles does 2 moles of carbon dioxide contain? Press the pause button if you would like to try it first. Let's take a look at what we know. We know that 1 mole is equal to 6.02 times 10 to the power of 23 particles. So based on this, if we were to calculate the amount of particles in 2 moles, we would have to multiply the amount of moles by the amount of particles in 1 mole, which is what is shown here. We do 2 times 6.02 times 10 to the power of 23 particles to get a grand total of 1.204 times 10 to the power of 24 particles. Now we are going to switch gears and look at the ideal gas law. This is represented by the equation PV equals nRT. It is important to remember what each of these variables stands for. First, P stands for pressure. V stands for volume, usually measured in liters. N stands for the number of moles. T stands for the temperature measured in Kelvin. And don't worry about R for now. Just know that this equation, which shows the pressure of a gas times the volume of that gas equals the number of moles in the gas times the temperature of the gas times R represents an ideal gas. Now we are going to take a look at some important relationships between the variables in the ideal gas law equation. First, volume and pressure have an inverse relationship. This means that as the volume increases, the pressure decreases, or as the volume decreases, the pressure increases. Pressure is how often the molecules of gas collide with the walls of the container they are in. Think about it this way. If there is more volume in a container, that means there is more space for the particles to move, which then means there's less chances of the gas particles colliding with the walls of the container, which means the pressure is decreased. We can also look at this mathematically. If N, R, and T stay the same in the ideal gas law equation and only V increases, what do you think will happen to P? P will decrease. Next up, temperature and pressure. Temperature and pressure have a direct relationship. This means that as temperature increases, pressure will also increase, and as temperature decreases, pressure will also decrease. If particles have higher temperatures, then they will move faster. This will increase the chance of collisions with particles with one another, which will therefore increase the pressure. Again, we can look at this mathematically. If n, r, and v stay the same and only t increases, what do you think will happen to p? P will increase. Next up, the number of moles and pressure. These variables have a direct relationship. The more moles there are, the more particles there are, which increases the chances of collisions between particles, and this will therefore increase the pressure. So again, if T, R, and V were to stay the same and N increases in the equation, what do you think would happen to P? You guessed it, P will increase. Now, what about the number of moles and volume? These variables have a direct relationship. The more moles of particles there are, the more space is taken up, which means the volume is higher. And the less moles there are, the less space is taken up, which means the volume is lower. So if P, R, and T stay the same and only N increases, what will happen to V? V will increase. And lastly, temperature and volume have a direct relationship. This is because the higher the temperature of the gas, the faster the particles move and the more space they take up. Because of this, the volume increases, and the same would go for the other way around. If the volume were to decrease, then the temperature would decrease. And lastly, looking at the equation PV equals nRT, if P, R, and V stay the same and T increases, what will happen to V? V will increase. Great job on getting through this lesson.